Like, that would be pretty bad if you got a
So, before we go over any questions, I just wanted to make sure we're good. I got to announce it every day to make sure we're good. Let's see. This is 5th period, right? So Zoe, who's not here, has a Unit 5 or the graph and quadratic functions makeup. Liz, you do as well. Sophia Montgomery, you have that as well, okay. Anything back further? Liz, you have the polynomial equation factoring to make up. Liz, you have the polynomial equations and factoring in class test to make up. Liz, you have the graphing quadratic functions quiz 1 to make up. Any more? Nope, you're good. So let's get at least one of those done this week.
Okay.
Good?
Yeah.
Yay. Thanks. All right. Page 99 was what we had, right? All right. Go. All right. Let me dim the lights. What questions?
23.
Yeah, go ahead.
22.
2 and what?
23.
23? Okay. Okay, number 22. So they have, they're giving us this. They said, hey, y happens to be equal to this big old equation. And then they said, hey, our a value is equal to 2, our b value is equal to 3, and our c value is equal to -2. So does everyone understand that this just is an equation that has like a whole bunch of variables in it, and they told us that these variables are equal to certain things? The best thing to do with these, and guys and girls, you gotta trust me on this one, don't try and do a bunch of this kind of stuff in your head. It doesn't work that way. Okay? Not because there's anything broken in your head, but you all have that Insta-Face, Snapchat stuff going on, and that's more interesting than math, I get it. So you start forgetting stuff because you are doing other things. All right, so I'm going to underline the constants here. Those two things that I underlined, those are just going to, they were always part of this. Does everyone understand why the 3 is squared? Well, the 3 is a b value, and b squared is what we're doing. And then the a value is a 2. Okay, and they told us that. And then the c value is a -2. And then we had another a value in the denominator, which is also a 2. And the 4 and the 2 that are underlined in yellow are like constants. They will be that way forever. All right, so we're going to do the math. Now, here's the tough thing with math. Ooh, I'm going to do it all right now. No. 3 squared is 9. You good so far?
Yeah.
Follow me on this. Ready? -4 times 2 is?
-8.
-8. -8 times -2 is?
64.
Positive 16. And then 2 times 2 is 4. Does everyone feel comfortable with that? You see how I got rid of that so easily? I just went right to left. I didn't, or left to right. And then we're going to do the math. So I'm going to get root 25 over 4. Square root of 25 is 5. So I get 5 over 4. Done. Cool? You like? Okay. You said 23?
Yes.
Okay. Is it possible to find 2 rational numbers that multiply to give an integer? So let's think about this. We got to remember what a rational number is. What is a rational number? Does anyone recall off the top of their head?
Isn't
Something
it just
that
like
fits
a
into
regular number and it can be decimal?
Almost. It's a little bit more though. It's a decimal that can be written as a fraction. Okay. So is it possible that I take 2 fractions, so a over b, and can I multiply it times another fraction to get an integer? What's an integer? A whole number, like 1, 2, 3, 4, 5, 6, 7, right? So is it possible for me to multiply two fractions together and get a whole number?
Yes.
Sure. I could have 14 over 2 times 2 over 1. Those are both fractions, agreed? Anyone like, I don't think that's a fraction. And I go 14 times 2, that's 28. 2 times 1 is 2, so I get 14. So absolutely, I can do that. What else did you see on the homework from last night that you would like to go over a little bit deeper in detail? Yeah.
Okay. Like I don't understand how to like convert like when it's written as a fraction form into like the regular form.
Okay. See, let's see if we can follow this. X, Y, and Z are going to represent any numbers I want. Sound good so far?
Mm-hmm.
So I can do this. I can make a radical turn into an exponent just by doing this. Exact same letters. Where did the radical go? Well, because I have a denominator as a fraction, that's our radical.
Okay.
And that's just the general form for them all. If you had like this, you have to understand that's the same thing as this, which is then the same thing as this. Okay, normally we don't see this 2 here when it's just a square root.
Okay, so when there's just a square root, there's always just a 2. Kind of like when there's x, there's always like a 1.
That's exactly it. What else did we see on homework that we want to go over? Yeah, no? No? Anybody? Yeah, 20. I don't know why it says 20.13. So I think just number 20. I think number 20 is just supposed to be this.
Oh, okay.
Is that okay?
Yeah.
Okay, I'll work it out anyhow. So we'd have to realize that this is the same thing as this. Is that okay? What's the third root of 8? 2. So if I do this, I'm going to get 2, and then I add that squared, so I get 4. Or I could have done 8 squared to get 64, and then the third root of 64 is 4 as well. It's 4 times 4 times 4. Anything else? Yeah.
For like number 14, you just rewrite the same thing.
Oh, yeah. And of course, I'm not reading directions. This is like, anytime my kids get a new toy, I try and put it together and I get mad because there's extra parts. So, number 14 says rewrite as a radical. Well, it's a radical. Classify as an integer, rational number, irrational number. So that happens to be an irrational number because if I did the square root of 7, it's a decimal that goes forever. And then evaluate the integers and rational numbers, or use a calculator to approximate. So if you did the square root of 7, I imagine you get 2 point something. And of course, it's a decimal this long. Am I looking to see if you can copy something this long out? No, I'd say like 2 decimals, 3 decimals at the most. Anything else you want to take a look at? We all happy? Good? Would you make sure your name is at the top of that? And hand that forward along with anything else? Please. Yes, sir.
For numbers, I got 36.
What was the original question?
It was like,
Why do you guys always look at me?
if you go back on your slide, it's there.
It's not smart. It's a smart. What's a smart? No, what's a smart?
Yeah.
30. What number was it?
What?
What number was it?
What? It was 22. I didn't say that. What? What? I didn't say anything. I didn't say anything.
You did.
22. Let's see.
I just replaced the values with the numbers.
Okay. But you see how that's a 3 squared, not a.
The old slack is up
So that you got a 9 there.
Oh my god.
What?
And then
That would be like she'd be
these 3 numbers are actually being multiplied together. So you get -4 times 2, and then times another -2. That gave me the positive 16. So 9 plus 16 gives me the 25. Square root 25 is 5. All right?
Gotcha.
Homework. 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 Yeah, over here, huh? Okay.
I know, he's really angry. Wait, whenever we don't win in Apex, he's like, it's because you're a dude.
What?
When we don't win in Apex.
What's Apex?
I don't know.
Well, I know, but like,
It's basically like another knockoff, but better. Way better. It's basically PUBG. Yeah, but like PUBG combined. But better than that. Still better than that.
did Jordy say he was going to
Excuse me?
Oh, yeah.
I hate it so much.
No,
It's
like
so
actually,
good.
did you actually call him?
I was calling about another kid as well.
To revive the.
One who's even
But I
missing.
told you I would never skip another class.
I know, but you came in late.
Yeah, I know.
So you skipped part of it. Right?
Part of the class, and you still have that granola from yesterday.
I had this going on in my backpack for like 2 weeks.
All right, ready for? Let's hit this.
They don't expire. It's granola.
All right, ready?
It did.
So we're gonna start breaking down numbers. Now, there's something that you probably heard a long time ago, and unfortunately your elementary school teacher read it out of a book, and you heard it, and then like 10 minutes later you're out at recess or lunch. But something's called a composite number. So let me refresh your memory. So if I were to take, say, the number 15, that's a composite number because 15 is the same thing as 3 times 5. So those are equivalent terms. Agree? And a perfect square would be like 4 because 2 times 2, you can have some number times itself. Get me there. So you have perfect squares, you have composite numbers, and then you have something called prime numbers. And prime numbers are like numbers, people say, oh, don't start with 1. They always argue about it, and it's like, dude, who really cares? So like 1, 2, 3, 5, those are prime numbers. They can't break them down any further because it's just that number times itself. Composite numbers are numbers that are made up of multiple prime numbers put together. So if I took a prime number like 3 and a prime number like 7 and I multiplied them together, I'd get a composite number of 21. Okay? So we're going to use that idea as we start working through these. So I think we can do the first one pretty easily. What's the square root of 16? 4. Is anyone like, dude? Where'd that come from? And then square root of 100? 10? Nope, not 50. 50 times 50 is 2,500. But close. So does everyone feel comfortable with that? Anyone like? And then we.
Sorry.
Okay.
For square roots, are you just kind of supposed to memorize most of them?
Yeah. Well, I think it'll give you those, and I say if you get up to about those, looks like we have the first 12. We don't really worry about 1 because 1's a perfect square, perfect cube, perfect fourth, fifth, whatever. Okay, so 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, goes all the way down, looks like 12 times 12 is 144. I'd say if you have those down, you're pretty much in an okay place. Okay, so those are perfect squares, and that's where we're looking at we start breaking down some of our math problems. So let's take a look at 300. Do what?
No, I'm okay.
15 times 15 is 225.
I can't spell square.
That's okay.
16.
So, but remember what we originally said in the very start of this. We said something about a composite number, which is basically 2 numbers being multiplied together to get to the third number. So, could I say that 3 times 100 is the same thing as 300. You good?
He said I was stupid.
No, we wouldn't say that. All right, so let me ask you this. Is this kind of the same thing as well? What do you think?
No.
Yes.
Is 3 times 100 equal to 300? Then root 3 times root 100 is equal to root 300, okay? So that verifies. Can I take the square root of 3 and get an exact number? No. Can I take the square root of 100? Yeah, what's the square root of 100? 10. So this has an answer of 10 square root 3. And it's preferred to have the whole number out front, and then the root 3 at the back. Yeah.
Wait, so I don't understand. So if it's the root of 3 and the root of 100, so 10 and whatever times it's
10 and a fraction.
then it's not 300.
That 10 root 3 is indeed 300.
But like how? Because it's not.
So do you agree with me that root 100 is equal to 10?
Yeah.
So I can interchange them. So can I take this root 100 and put it right here where that 10 is? If I do that, then I get root 100 times root 3?
I don't understand the 3 part because the root of 3 isn't.
Yeah, it's something that we don't know. It's an irrational number.
Oh, okay.
So we leave it like that. So that right there is called an exact answer.
Okay.
And I'm going to come back to exact answers in a moment. And it's going to hopefully help you all a little bit. Yes?
So I think kind of going off of that, it's like the square root of 3 times the square root of 100. So wouldn't it be like whatever the square root of 3 is times 10?
Mm-hmm. But the square root of 3 is like 1 point, a decimal that goes forever.
Yeah.
And so we want to keep an exact answer. So I'm going to answer now both your questions on this. Okay, so let's think about this. Does everyone feel comfortable that if I were to do square root of 3 on a calculator, it's going to be a big decimal? Does everyone agree that the calculator has to have something in its programming that says, hey, stop after this many decimals? Does that make sense? Because if it doesn't, a computer knows how to turn things on and knows how to turn things off. That's all a computer does. It's on and off. Zeros and ones. Okay? The calculator is a computer. So you have to plug into the subroutine that you will only take something out so far. And how it calculator is doing it is if it keeps computing, if you hit square root of 3 and hit enter, it would go until the batteries died. Okay? That's the limit to that calculator. So you have to say something like, you know, we're going to truncate off after 9 decimal places or 10 decimal places or 50 decimal places. I'm a big jerk, but y'all know that. When I was down in Douglas County at Chaparral High School, us math teachers had to go to this fancy dancy math meeting. And I was on this computer, and it was a rival school. We'll just call it Rock Canyon because that's where it was. And I hit, y'all know that pi never ends?
Yeah.
I found
Square root of pi.
No, square root of pi won't end either. So I just said, okay, wrote a little thing and did a search for pi out to 6 trillion places. I don't know if you know what 6 trillion looks like, but as the thing was ending, we were just on these module computers. I hit print and walked.
Oh, that's nice. That's such a nice thing to do.
500 sheets.
It's a waste of tree stuff.
I know, but they grew back, so I don't feel too bad.
They take like hundreds of years to grow back.
No, don't worry.
They take like years.
And they won't even grow back
You know what?
because they're
You're only
clearing all
saying
the
that because
forest.
you're dying
Don't-
before us.
I am?
Dude,
No offense, but it's true.
Here, do you want me to make you feel better about ourselves as a nation? Do you realize that right now in the United States, we have more trees in the United States than we have ever had before in the nation's history?
then why do they I know, but corporations in the United States are cutting down like the Amazon rainforest and so. And
Yeah, but us in the United States, we got more trees. So
No, bro,
I'm gonna find the statistics that makes me look good. Now what makes me feel
But
bad?
like animals are like losing their homes for money.
They can find
Hey, it's not my fault they don't know how to use cement and build a house. And
I don't think it's us that are cutting it down. It's those like, those like big bosses in Rio, and then they like have like.
yeah, I know. But I was just trying to make us feel good about ourselves that we have more trees in the United States than we have ever had in the history of the nation. Makes me feel good.
That is good. We're very green country.
Yeah, we just deplete everyone else.
Yeah, we do.
There's your history lesson for the day. All right, I don't know what this is, so we're going to move it on. Okay, so
The United States is the
we used some of these perfect squares. We used some of these perfect squares in order to make this work. Okay, do you remember seeing something called a tree diagram? Do you remember that a long time ago? And a tree diagram is like, okay, what's the smallest number that goes into 300? Well, 2 does. 2 goes into 300 150 times. Remember that?
Yeah.
Well, 1 definitely does, but that's not going to get us anywhere. But 2 is going to break it down. And then I can say, well, 2 is going to go into this 75 times. Do you remember that? I don't have to break this down any further because it's already broken down. And then 75 can be broken down to 3 and 25, right? And then 25 can be broken down to 5 and 5. And any pairs of numbers you have become a perfect square if you multiply them together. So any pairs that you have become that. So that means that the square root of 100 is the same thing as 2 times 2 times 3 times 5 times 5. Does that make sense?
With the square root of 300?
Square root of 300.
I thought you
broke.
said 100.
Oh, I might have. All right, so let's break this up a little bit. Is that the same thing as 4? And is this the same thing as 25? And 4 times 25 is what? And then the square root of 100. So again, we did the exact same problem. I'm just trying to show a little bit different version so you can see how things break down. So I have this tree diagram that we break it down into its prime components. Remember, a prime number can't break down any further. We get there. Seem all right? Can I move forward? Okay, so think about what 48 is to break down. Now, I know we can go on our calculator, square root of 48, you're like, hey, it's 6 point something forever. But let's break 48 down. So, question 1, do any of those perfect squares up there divide into 48? Does 4 go into 48? What do you think? Does 4 go into 48?
No.
Yes. 4 times 12. That works. Okay. So I know that 4 is going to work with this. Let's try something bigger. Does 9 go into 48? I don't think it will. I don't think, because 9 times 5 is 45, so 9's not going to work. What about does 16 go into 48? Yeah, 16 times 3. And then, so that works. What about 25? No, 25 won't work. 36 won't work. 49 won't work. Good. So which would be the better pair to use? The 4 root 12, or the 4 and the 12, or the 16 and the 3? What do you think?
Would it be 416?
So let's just write this 2 ways. I'm going to write this way, and I'm going to write it this way. These both get us the exact same answer. Do you agree?
Yeah.
But what is wrong with 12? So this should break down to 2 square root 12, and this should break down to 4 square root 3. Can I break square root 3 down any faster? Any more? Does it break down to anything? No. Can I break square root 12 down? Yeah, 4 still goes into 12. So this is the appropriate answer here. Okay? So you're looking for the largest perfect square, that's going to be part of the number.
Wait, I don't get it.
So
Why 16 times 3 right and not 4
because
times 12?
I can still break 12 down. 12 would break down to this. And this square root of that is going to give me 4 root 3. It's still going to give me the exact same answer, but would have to continue breaking things down. The reason that gives me a 4 is because square root of 4 is 2. 2 times the outside 2 is 4. So there's the same answer. It's just if you find the largest perfect square first, it's going to work out nicely.
Oh, so the largest perfect square is it doesn't break down as much.
Idiot.
Okay, I thought it was the opposite.
Yay. Ready? Let's see if we can I move on?
Yeah.
Okay. Try it. See if you can figure it out. See if you can figure it out. I think it's like 144 times 2 is the same thing as 12. I think. What? I used 4 and 3 because 4 is my largest perfect square that works. I'm not going to use 6 and 2, though 6 times 2 is indeed 12. 4 is the largest perfect square that works. So what should my answer come out to from here? 2 root 3. Awesome. And very well said. Giddy up. Okay? 6 root 2 isn't, or root 6 times 2 is not incorrect. It's just it doesn't break down as quickly. May I move forward? Ooh, try that 72. Try and figure out the largest perfect square that's going to work there. What? Oh, squeeze it in there somewhere. I'm sorry. I don't know where it went. Oh, no. Oh, boy.
Is it negative 3 square root like 12?
Do what?
This is what we have.
Oh. Wow. I don't know where it went. I must have eaten a page. I'm sorry. All right, so let's just try this one. So some of you might be choosing 8 times 9, which comes out to 3 root 8. You're like, yay. But some of you might have seen this. Which one seems to be the most factored down version? Yeah, 6 root 2 is most factored down. Can 8 be broken down further? Yeah, that breaks down to 4 times 2. Okay, so that's why that path isn't the best path. So you look for the largest perfect square, and in this case 36 works. Even though 9 does indeed work, this is the largest perfect square that works. And that's the key to doing this. All right, let's see if I can actually get us caught up. We discovered that slide's not there. Is this slide on your paper?
Yes.
Yay!
No.
Okay.
No, it's not.
No.
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 Is
Yeah.
that one?
Yeah.
So not that one, but that one.
Yeah.
All right, let's just work through it. Okay. If it's outside the radical, you can multiply. So I'm going to multiply those together. What do I get if I multiply those together? Watch your sign. Negative 12. If it's inside the radical, you can also multiply it together. What is 12 times 3?
36.
36. Can I break square root 36 down?
Yes.
What does it break down to? 6 and 6. So what's the square root of 36? 6. So this becomes this times 6. Does everyone see where the square root went? And if I multiply those together, I'm going to get negative 72. Done.
Wait, since the square root of 36 is 6, why do you multiply it instead of like square rooting it? Like,
Well, so from here to here, I take the square root of 36 and I get that.
Mhm.
That's why the square root sign's gone now. But I still had this negative 12 that was being multiplied times it.
Okay.
Okay, hopefully you have the next slide. Do you have this slide? Yeah, you've seen this before? Now, you've only worked with the Pythagorean Theorem like once in your life. You have A, B, and C. And what the Pythagorean Theorem means is if I were to take the square and the square, and let's pretend I can draw really good squares. If I were to add up the area of the A square and the area of the B square, it would equal the area of the C square. Okay? So that's where the Pythagorean Theorem works. This was a theorem that was figured out in the 6th century. Pretty cool, by a guy named Pythagoras. His best friend was Isosceles. Equilateral, they didn't like all that much. All right, so I'm going to use the Pythagorean Theorem. So does everyone feel comfortable to say, hey, I have a right angle right here? Is that okay right there? So then I have a squared. Is that okay so far? Plus 8 squared is equal to 10 squared. Okay? So the Pythagorean Theorem says that the sum of the squared legs of a right triangle will equal the hypotenuse squared. Okay? And the hypotenuse is always the longest leg of that. So let's use a little algebra. A squared, I don't know what that is. I'm going to have to figure that out. What is 8 squared? 64. What is 10 squared? 100. So then, Algebra 1. Help me out, Algebra 1.
Oh, you did the minus 64.
Yeah, subtract 64 from both sides. Awesome. So those cancel. So I get a squared is equal to 36. Ooh, okay. Last little move. I'm going to take the square root. I'm going to take the square root. So a is equal to, what's the square root of 36?
6.
So my a value is 6. Okay. That's pretty happy. So that's when we're trying to find one of the legs. Let's do this next one. Can I move on? All right, here's one more. Okay, so my two legs, I have this. So I have 2 squared plus 6 squared is equal to c squared. Is that okay? 2 squared is? 6 squared is? Equals c squared. 4 added to 36 is 40. So let's bring that kind of up here. So I have c squared is equal to 40. So if I want to get c all by itself, I want to take the square root of both sides. And I think I can break 40 down to 4 times 10. What do you think? Because 10 is the same thing as 2 and 5, so there's no pairs. So what is c actually going to be equal to if we broke this down completely? What's the square root of 4? 2. Root 10. Done. Yes?
Why don't we do the square root of 10 too?
Because 10 only breaks down to 2 times 5. So I can't do the square root of 10 and get an exact answer.
Oh, I see.
Okay? So
Wait,
here.
how are you supposed to know, like, if it's bigger if it takes longer to, like...
So you need to have those first 12 perfect squares down.
Oh.
And you really just look at those and say, can I break my numbers down?
And then it'll be easy.
I mean, what I would do if I were you, I would just write the first 10 perfect squares on the back of her arm. That was his arm, so you can see it. So, all right. So your assignment for tonight is going to be page 101 and 102. 101, 102. You do it okay?
Aiden,
This is a